for this industry in the state of Oregon, this is really a land grab moment for us. It's really a question of, do we build this industry here or does someone else build it elsewhere? So really, I can't thank these sponsors enough. And so, as I said, these are the 12 companies. Here are the 12 startups that'll be presenting. We split them up into two groups today. So session one, that'll happen right after I speak. Our Frontier UAS Technologies founders are pushing autonomy, sensing operations in extreme environments on, below, and above the planet, and remote exploration to human-centered uses. Um, Session two, which will happen right after our lunch and networking at 1:05, is all defense, security, and counter UAS solutions, including mission-ready threat detection, protection, rapid deployment, and breakthrough 3D printing for in-theater drone production. Each of the startups will make an 8-minute pitch, followed by 2 minutes of Q&A with our judges. We'll announce the judges' overall prize winner and the fan favorite of the People's Choice Award just after, or maybe just before our break at 2:35. For the fan favorite voting, please scan the QR code. It'll come up when it's time. Scan it with your phone and please kind of cast your vote. So after the pitches, all of our startups will gather kind of in this area over here, along with our judges, investors, strategic partners, and sponsors. So please stop by for deeper conversations. And we'll announce the judges' overall prize and fan favorite here at 2:35 before the networking break. So, with regard to our judges, we can't thank you enough, uh, for volunteering your time to serve as a judge today. Our first judge is Lieutenant Colonel Mark Timmons of the Oregon Army National Guard. Mark, where are you? Oh, back there. Okay. Uh, we have Alex Thomas, Oregon Department of Aviation. If you just want to wave your hand up there. Yeah, awesome. We have Josh Olds, who is the president and CEO of the Unmanned Safety Institute. Josh. We have Ben Parrish, who is the vice president of startup banking at Silicon Valley Bank. We have Ian Anase, founder of Zing Drone Solutions. We're super proud of Ian because Ian is a former cohort member of our program that has been extremely successful here in Oregon. We convinced him to move to Oregon from Florida. So he soft landed here in pictures here. I forgot to scroll. And so after the pitches, all of our startups, again, will gather in this area. Please come by. So welcome to session one. We'll have our first startup pitching, and we're ready to go. So Shashank, if you're ready, let's come up and
Well, very good morning, everyone. Am I audible if I talk from here? Okay. All right. Good morning, everyone. I'm Shashank Reddy Goli, and I'm the co-founder and COO of Ganayo. As Tesla engineers, my co-founder and I broke away to reinvent suspension technology by making premium ride quality more affordable. Within the suspension of a vehicle, the damper defines control and comfort. But for over 100 years, they relied on oil, preventing the industry from being able to deliver premium ride quality at mass market value, mainly due to early wear, costly manufacturing, and inconsistent performance that is inherent to hydraulic dampers due to loss of energy in the form of heat. The industry has attempted to solve this problem using electromagnetic damping, as demonstrated by some companies, but these are often too complex and expensive to scale. Automakers still lack a solution that can bring premium ride quality at mass market cost. And that's the gap Ganayo is built to solve. To do that, we developed the first fully passive magnetic damper, delivering electromagnetic performance without the need for oil or complex mechanical parts, enabling 44% more damping stability and control, 33 times the wear life, and 6.9 watt hours per mile in net positive regeneration. And we are semi-active ready, which means an electric load can be added for high performance applications where we can customize what the suspension can do for the vehicle. This has been demonstrated by our TRL5 prototype, where we've seen 3.4% lower hysteresis energy, which means there's less losses due to friction. And we showed 44% lower force variability, which means the damper responds that much quicker to the deflections on the road. These results outperform the competition very distinctively. And this is due to the absence of oil, which would otherwise cause cavitation and heat fade. Our technology is primarily protected by a utility patent that outlines a dual magnet arrangement, which helps us maximize the magnetic field strength within any given volume. That helps us to produce damping forces through what are called eddy currents, which no one else is doing in the market currently. We're at a TRL6 validation level currently, where we are integrating our dampers into actual vehicle platforms for real world validation. Our long term target customers are automakers, where hydraulic dampers traditionally currently cost about $577 per car set. And there are other electromagnetic dampers out there that are available, but they're often a lot more expensive, as with Magneride being the one closest to a traditional damper, but it is still more than twice as expensive as a traditional damper. So Ganayo is the only damper that can be close in cost to a traditional hydraulic damper while still outperforming the other electromagnetic options available out there. If a Ganayo damper were to be installed on every vehicle made globally, we arrived at a theoretical 5-year TAM of $137 billion at a $547 ultra high volume pricing. And our SAM focuses on premium vehicles, which would narrow that target down to about 18% of global production at $25 billion. Our SOM is from forecasted sales of aftermarket and OEM partnerships at $34 million by 2030. And this is only 0.14% of SAM penetration based on what we're forecasting. Our business model starts with high value aftermarket segments, like with the Army looking for high performance and endurance in field operations, EVs looking to maximize energy efficiency, and off market customers, off road customers looking for better ride stability. These are customers willing to pay for better suspension performance, and this will provide us early revenue and also more real world validation. In parallel, we're also running uh, pilots with our pilot partners, which will help us cascade into, I'm so sorry, guys, which will help us cascade into higher volumes and generate per unit revenue. We currently have 17 engagements from the industry, all of which are ready to convert into pilots once we reach TRL7 development. At our current development stage, which is TRL level 6, we have 3 commitments, including the Oregon Military Department, where we are pursuing testing our damper in the field, and Slate, one of the OEMs, and Schaeffler, a tier 1 supplier, are pushing for a semi-active version of our damper. Our 5-year projection looks at the first 2 years for TRL7 and TRL8 development, followed by scaling manufacturing from 50 to 4,000 parts per month. And this includes both OEM and off-market variants. So our aftermarket launches in 2027, which will be fulfilled in 2028, where revenue starts generating. And towards the end of 2028, we transition into OEM level participation, and that will launch us into per unit revenue, where breakeven occurs in 2029, and our TAM scale and our EBITDA scales to $12.5 million by 2030. We first got introduced to the automotive market when we won the Automotive Engineers competition, following which we received our first investment from Generator in the form of a safe. And after our TRL 6 validation and with the engagement that we have generated with our customers, we are fundraising now to get us through the next levels of product development. We are raising a 3.25 million targeted price, and this is to get us through TRL 7 and TRL 8 development stages with our pilot partners over the next 12 to 18 months, following which we will be positioned to start OEM partnerships and also start launching our aftermarket products. Together, we have the team to take this from prototype into production and into the market. John, our CEO, comes from a background in automotive systems and electromagnetics, and he's leading both product and company strategy. I come from Tesla with large scale manufacturing experience, having led about 100 people in delivering over $100 million in capital equipment deployed and long term cost optimization. Noel comes with 15 years of experience in branding and growth, where he will be able to help us in translating complex technology into clear market positioning. Andrew and Eamon are joining us from Qualcomm and BAE Systems, where they have deep expertise in robotics, linear actuation, and coil system design. And they have been involved in developing systems for both commercial and military applications. The market is clearly telling us or showing us that it is seeking a solution like ours for constantly evolving vehicle platforms where a product like ours finds a perfect fit, since these platforms are looking for higher ride quality, lower complexity, and reduced energy losses. So Ganayo comes to the market at the right moment in time, and we would love for you guys to join us. Thank you so much.
Thank you so much, Shashank. So we have time for one question from our judges. Who would like to ask that question? Anybody?
Shashank, thank you very much for the presentation. Can you elaborate a little bit on your IP and the defensibility?
So our IP basically protects the arrangement of the magnets the way you see in this picture here. So what that gives us is it protects the way that we engage both the inner and outer ring magnets, as you can see. And what this gives us is defensibility against anyone trying to have a similar arrangement, regardless of the application. They might be going for linear actuation, they might be going for suspension, they might be going for any other application. But as long as the arrangement and the way we have it has any similarity to what they are trying to do, then we still have maximum defensibility against it. Thank you so much.
Thank you.
Thank you, Alan. So next we have
Test, test. Yeah. So next we have founder, co-founder, and CEO Farzad from FlyX. So welcome him to the stage.
Good morning, everyone. I am Farzad Rahbar. I am the CEO and co-founder of FlyX Technologies. At FlyX, we are on the mission to turn the grid into charging grid for the power line. Basically, we the mission to change the power lines into charging grid for drones and unleash a lot of applications that are not possible today. Let me walk you through the problem. The infrastructure is critical infrastructure is failing, and we can't see the problems in time. The reason is, like, for instance, in the grid is largest man-made machine. It goes through. There's a lot of inaccessible areas going through, like mountains, through over the rivers, and the tools we have are very manual, costly, and dangerous. People literally die while doing inspection on these power lines, using helicopters or trucks or even hiking to see these assets. And the process is very manual, fragmented, and there is a huge regulatory pressure on the asset owners. So that leads to a very a large data intelligence gap between what we know and what's happening. Basically, there's a lot of unknown unknowns. And in most recent years, as you know, there's been several catastrophic wildfires that's been started because of failure of old and aging grid, and costing billions of dollars in fines. Good news is that FlyX, we have a solution for this. We want to launch an autonomous fleet of swarm drones that are able to use the existing infrastructure without adding anything to the infrastructure, cross and equipped with edge intelligence and AI, process the data in real time, achieve autonomy, and digitize this process, and achieve regulatory compliance. You may wonder how we do it. Basically, there is an energy around these power lines in the form of electromagnetic field. At FlyX, we figured out a way to use that low frequency energy source and improve the state of the art by 100 times. So basically, our device is a small device, a receiver that we put underneath the belly of the drone. Drones go fly, land on the power lines, charge, take off, and continue, rinse and repeat. Basically, like little guy that you see on the wire, all of them sitting on the wire, similar case. So we want to provide that persistent infrastructure intelligence for large asset owners. Why now? Basically, we're living in a time where a lot of technologies are coming together that making this possible. Basically, drones now are commoditized. You can buy parts off the shelf, or can 3D print a drone. NVIDIA is providing us with the Jetson computers, which are able to process data in real time on the edge, and they're low power but high processing units. And Starlink, thanks to Elon Musk's beaming electric connectivity, NASA has come up with a traffic control management for UAS, and FAA just released 108 framework, which is geared towards more like beyond visual line of sight, and basically targeting electric grid as well. And at FlyX, we are able to provide that unlimited energy to combine the 7 layer of technology and integrate them software, firmware wise, and hardware wise, and build this new economy that's emerging between 0 to 400 feet above the ground, where drones can fly and grid exist. So imagine all long linear infrastructures, from electric grid to pipelines to railways to border to delivery to any application that is possible, and the technology works anywhere in the world. So the TAM, SAM are very large, the numbers are there, and we are actually creating new market category, as well as provide also developing a new competitive or drone category. This is the next generation of autonomous drones, which is, compared to competitors in the market, it doesn't need any ground stations for charging or battery swaps. We can process the data on the edge in real time. And as far as we know, we are the only company we can keep that computer up and running thanks to our wireless charging. We have unlimited flight range, and we are already in autonomy level 4, pushing to 5, and 6 and 7, which is going to be swarm, and we will be defining that. So in terms of business model, we have two business models for depending on the P&L of our customers. We're targeting energy utility companies beginning. Some of them, their procurement is like they want to buy capital, some they want to buy services. So depending on that, for the services we deploy each drone $2,000 per month per drone, and the capex we sell the drone 10,000 each, plus they get $10,000 licensing fee per user per month to our AI dashboard, and we are extracting value from every single um, value stream that's out there from hardware, software, and data, which is the main gold here as we develop and carry and capture is this data. And we will be going after small utility companies. These are cooperatives, then moving on to the larger electric utility companies like PG&Es of the world, and then other defense and delivery applications as we move forward. So we are in the pilot process right now with the smaller companies, and then as soon as we have like a pipeline of 5 customers. And as soon as we finish these pilot projects, we anticipate a domino effect with the rest of the customers because grid is the same, physics is physics, wires, wire. They're all dealing with the same problems. The only matter is that they have different asset size is different. Some people own more, some of them less. So we founded the company in Bellevue, Washington, with my founder. Invested our own money into it. We developed the tech in 3 years in stealth mode, and then we patented it. We built the wireless charging prototype. We filed our non-provisional. We raised 500,000 from Silicon Valley, Plug and Play, and other angel investors. We got LOIs and MOUs worth of $50 million in value, and we built our first MVP of autonomous drone, which is available for demo next tomorrow. You're more than welcome to see it. We're raising $6 million to convert these pilots into paying contracts over a year and a half from now, and also execute on our regulatory BV loss plan, where we're getting help from experts on this from electric utility side and also FAA, and hopefully in preparation for our Series A raise in a year and a half from now. We're a team of 12, 14 now. 12 was 2 weeks ago, so 14. At the core, it's Kamyan and I. I am an aerospace engineer. I am a graduate in Imperial College London, Stanford. I was a jet engine designer, Rolls-Royce, been building planes for Lockheed Martin and Boeing. I have a passion for anything that flies. And It's my second company. Kamyan is a PhD in electrical engineering, expert in wireless charging and IC design. We both work for very large companies, and companies have been acquired and startups. We are accompanied by world-class advisors with Stephen he run their drone program for the past 35 years. He's actually retired with Intel. James has sold electric companies for the past 16 years. Ray is an awesome guy. He's Wharton MBA. He's launched CVC Arma, IBM and HP. And Jeff is a superstar with exiting to AI and robotics company, ex Carnegie Mellon to Microsoft. So just remember this, as roads has enabled automobiles, power lines will enable autonomous drones, and we are building that future and hopefully hope you can join us. Thank you very much for listening. Thank you.
Sure. Hey, thanks for the presentation. I just have a couple of questions. Firstly, about the business model. So, for the power lines specifically, do you have to work with the owners of these power lines? Are you capturing energy from them? Is there any kind of like a meter that you need to put on the drone to calculate how much energy you are using from these power lines? And secondly, if you charge for the attachment mechanism to these drone OEMs, are you saying that you're charging $2,000 per month for the installation of this charging mechanism onto the bottom of the drone, and you can integrate that with any drone manufacturer?
Thank you very much for the great question. So the first question is basically this energy is being like leaked from the power line. That's just physics. And yes, we have the capability to meter that energy and pay them back. And we work directly with the companies, which is electricity companies themselves. We don't go just land on people's assets, right? Because the main reason we started this company, one was to save lives. Second, because of helicopter crashes, 25 people die in the US while inspecting these power lines every year. And second was the wildfire, trying to help them to go technologies, right? And then now trying to integrate, it's possible, but with any aerospace vehicle, you have to design things from ground up. So we are able to provide whole drone as infrastructure. We figured out a way to build these drones cheaply, and as I was saying, it's like commoditized. It's cheap, like it's $250 for a Jetson computer. You know, if you add them up, it's around $5,000. So we kind of deployed them $2,000 per with our dashboard. Thank you very much.
Thank you so much, Farzad. Next up is Jeremy. Jeremy, are you here? Here we go. Jeremy Anderson with ORE, Outer Rim Exploration. Jeremy's connection to Oregon is that you're originally from the Salem area?
Yes.
Yeah, Salem. So, stage is yours.
Hello. So critical minerals are in huge demand, but there's a big gap in our ability to see what's under our feet more than a few meters. It might as well be in deep space. We've developed a novel method to map the underground, and we're using exploded star energy to do it. Let me tell you how. How much do you think it costs to discover a new mineral deposit? Rhetorical question. It takes hundreds of millions of dollars, 5 to 20 years, and 95% of the time, mining companies are just missing. That's because mining companies are using traditional methods. They send teams of experts to very remote locations. They use thumper trucks, explosives, power-hungry sensors, and in the end, at the highest risk, most expensive phase, they drill. They drill 200 times on average per square kilometer to pull up samples of the underground to prove an economically viable mineral deposit. Needless to say, the mining industry is well aware of this huge bottleneck, but their solutions are not great. They try gravity surveys, but they're low resolution and they fail for many geologies. They try seismic surveys, but they're extremely expensive. They have terrible deep resolution. Our solution instead was actually made famous in academia more than 10 years ago by the discovery of hidden chambers in the pyramids of Giza. It's called muon tomography. We've developed a novel, commercializable, scalable way to do this, which can reduce mining companies' costs by in excess of $10 million per square kilometer survey, speed up discovery of critical minerals to less than 6 months, and reduce the number of missed drill attempts by up to 90%. So what is a muon? So muons, believe it or not, originate from star explosions, supernova explosions happening throughout the history of the universe. When a star explodes, it creates a cosmic galactic ray. Turns out these are showering the Earth from space continuously. So we deploy our novel hardware at the surface of the Earth, and we measure the absorption of energy of muons generated from these star explosions. It's like a passive CT scan of the underground. By doing this, we can generate 3D density maps and locate mineral deposits. In just 6 months, which is 5 times faster than academia, we finished building our first product. It is the mounted hodoscope on the left. It's 10 times lower cost, it's higher resolution, and it works just about anywhere. We're also developing a narrow borehole version of this product, and this will fit in 95% of the world's drill holes. And in addition to that, we have a novel AI-based 3D density mapping pipeline. So we have patent protected hardware, but the software is also very challenging. We're using particle physics simulations as well to generate the 3D density maps. So this is not your typical Silicon Valley startup. It takes a lot of competencies to pull this off. I've been leading groups of PhDs to commercialize cutting edge technologies related to AI and physics for more than 10 years. My previous role was in a top new space company in Japan where I was head of product. I stepped down from that when we got funding from UC Berkeley Skydeck, and we rapidly built the product. We've got experts in electronics engineering, a PhD in astrophysics, mechanical engineering. We're advised by a longtime executive of the mining industry, and also by the man who coined the term muography in his famous Nature paper, Professor Tanaka at the University of Tokyo. So how do we monetize this? We charge the customer $1 million per 5 square kilometers surveyed. We generate a 70% profit margin.
So the market size is very large. $7 billion is the size of the mineral exploration geophysics market alone, and that does not even include the cost of drilling, which we reduce. In the future, the same exact product can be applied to other industries such as defense, infrastructure, and even space. We're talking to DARPA right now about applications for lunar subsurface exploration, worth much more than $70 billion. So in terms of traction, we built it rapidly, and within weeks, we had our first customer. We're at TRL level 8. I'm happy to announce we just finished a survey in Idaho. We discovered a copper deposit and validated against ground truth data. We generated, that was a local survey. We generated revenue from that. We also have soft commits of more than $240,000 from mining mid-tiers and juniors. On the partnership side, we are partnered with Lawrence Berkeley National Lab, Colorado School of Mines, and NASA JPL. Also Rio Tinto, sorry, I can't mention that, huge customer for rare earth element survey under the Department of Energy. So this is our trajectory. For the first 2 years, we're actually focused on services. We're boots on the ground. We do the survey. However, we transition to leasing our hardware to the end user. They push a button, they set it, they forget it, and they get daily near real-time updating density maps. The geophysicists decide when to drill the next hole after they've seen the density maps. In this way, we can scale very rapidly through channel partners such as IMDEX. And our vision goes beyond. We plan to do an IPO, and we'll expand into many other verticals for which we've done a lot of validation. We can tell you more about that later. But our first niche is definitely the mining industry, which has huge demand for density maps. So we are raising 2 million in safes right now. So far, we've raised $500,000. And so with this investment, our target is to generate 1 million in revenue in the next 18 months with 3 square kilometers of surveys. We'll deploy our second generation novel borehole hodoscope. We will ramp up the number of our mounted hodoscopes to 10, complete 3 to 5 brownfield deployments. In addition to this, we've also have $3 million plus in grants with decisions coming soon with the Bezos Earth Fund and Department of Energy. I just want to finish off by saying there's really no better time than now to be a mining or mining services startup, and at least for the past 50 years. This is being driven by the AI boom, which needs copper and electrification, and also the obvious geopolitical contention, and this is not going to change anytime soon. So if you're interested in investing, please come chat to me. Happy to answer any questions. Thank you. Exploration drill holes. So this will help to fund that. We'll hire another electronics engineer as well.
Jeremy, I have a question. So can you give me an example of a defense application?
Yeah, so DARPA reached out to us to ask if we can find subsurface ice on the moon. So at the March 26th, the NASA announced the plan to return to the moon with a permanent manned base. But the problem is we don't know where to build a base. You need a large ice deposit for oxygen, for hydrogen, for rocket fuel, human sustainability. We can find that ice. So this, because of the race, frankly, there's a new space race against China right now. DARPA is very interested in this. So space exploration, this is probably the best technology for prospecting the moon, asteroids, and Mars. There's research to back that up. Other defense applications, more obvious ones that are higher TRL would be border monitoring. So we can find hidden tunnels, hidden bases, North Korea, Mexico, or we could spot those Americans running across the border to Canada before they leave.
Thank you so much, Jeremy. I appreciate it.
Yeah.
I don't think so, but our startups will be around here, so you can ask.
Hey, thank you very much. Thanks, Joseph.
So next up, I want to, he's already up here. Joseph Piacenza with C Stereo. Welcome, Joseph.
Yeah, thank you so much.
Yeah.
All right. Okay, I'll go ahead and get started. So thanks so much for the introduction. Oh yeah, maybe the computer's not going to work here. You could pick the line. Okay, again, my name is Joe Piacenza. I'm a mechanical engineering faculty at Oregon State University. Also the co-founder and COO of C Stereo. Okay, so we're going to get started talking a little bit about the global seafood crisis. So you guys may or may not know this, is that half the planet actually relies on oceans and rivers as their number one source of protein. So, however, got it. As you can imagine, so this natural resource is being decimated, right? Because of things like overfishing, pollution, climate change. Okay, and so fish farming, like cattle farming, it's called aquaculture, is a viable solution. However, this is a profoundly labor intense process. So over 30% of production costs go into physical labor. So C Stereo has actually developed a technology to automate this process, pulling for the most part the human out of it, so reducing labor costs by 75% and increasing yield prediction from 60 all the way to 95%. Okay. And so thinking about aquaculture and specifically in the US. So back on the previous slide, you saw that slice of the market. So globally, the US aquaculture is 350 billion and the US has less than 1% of that. So in my mind, that's a missed opportunity, right? And it really boils down to the aquaculture unit economics, okay? And so you can imagine raising fish, not dissimilar to raising cattle, is that you need to know with how many you start at the beginning, how big they're growing along the way, how many you still have left at the end, and how much you can sell them for. So if you're a commercial fishery, this is, of course, your yield, right? How much you have. But then think about government agencies such as state facilities that are growing for wild stocks. They need to know and make sure that they're meeting their quotas. And so right now, this current labor intense process for management truly involves scooping up a subset of the fish. And this is hundreds of thousands and into the millions, counting them in this, what we call fish in the bucket method. Okay. And we extrapolate that information to the rest of the population. So you can imagine this isn't particularly accurate. So in addition, the mortality rate is really high using this contact process. So 30 to 50% mortality rate. So it's hard to convince people to invest in aquaculture in the US when almost half the fish are going to die, right? It's not a particularly sound plan. Okay, this is a picture, and I'll just note on the bottom right is specifically. Unfortunately, the video is not playing, but this is two technicians at a hatchery, and that's what they're doing right now. They're gathering up a subset of the fish, getting ready to count them. Okay. All right. So now the question is, how do we actually solve this problem? So, like I said, we're taking the human out of the equation, and essentially, we're using our hardware looking from above, from the air, into the surface of the water, right? So here we can count the quantity of fish, we can measure the length, subsequently calculate morphometrics, and we can give this information to the aquaculture technicians so that way they know how much food to feed the fish along the way, again, how many they have left, and where they're looking at the end. As a side note, 50% of the costs are actually food. So it seems crazy in my mind to be feeding fish that no longer exist, right? That haven't made it along the way. Okay. In terms of our IP position, I really just want to highlight what we've been doing in terms of our AI modeling and training. Okay. And so, regardless of resources, someone couldn't just come in and replicate what we've being done, right? So, over 1,000 hours of this very specific training in terms of counting and specifically looking at morphometrics of fish. Okay. So we talked about aquaculture market in general, right? 350 billion, but let's move that down to what I call precision aquaculture. And so still a large global market of 150 million or billion. And so what this is things like sensors and hardware required to support the aquaculture infrastructure. So moving down that funnel a little bit more, we're going to be targeting the US specifically. And so if we just think about capturing a small piece, in fact, 12% of that market, in 5 years, we can get to $63 million based on our assumptions. And let's hold on to that number because we're going to talk about it more in detail later. Okay, so C-stereo competition. So where are we at? We're not really competing against other companies. We are truly competing against what people are doing now, right? So this fish in the bucket approach. And so yes, while there are other competitors in the space, some of which not necessarily in the US, but Europe have been in the business a little bit longer, So, respectfully, their equipment goes into the water. They're still dealing with hardware, data cables, power lines in the water, things like biofouling, and do not have the accuracy that we have. So, again, the only system that exists that's from air into the water. Okay, so our revenue model is really derived on the tremendous amount of customer discovery that we've done. So we've visited up to over 40 facilities and almost 100 customer interviews, really trying to understand the problem to make sure that we're designing a product that solves a pain, not just that we happen to have a technology that matched you. And so this hybrid hardware software approach seems to be working really well. And again, it's just set at 3 tiers based on the fact that there's a distribution of different aquaculture facilities, right? Okay, so our business model, I'm not going to get into the weeds. This is a snapshot of just year one based on our assumptions. Really, the thing I just want to highlight is the 71 profit margin. Okay, 71%. Okay, our go-to-market strategy, we're looking at a combination heavily between state-run hatcheries like Oregon Department of Fish and Wildlife and then commercial companies, right? So that's going to be the chunk of it. And then just a tiny slice of web-based just for brand recognition, right? So people know who we are. Okay, so back to how we're going to make money. So kind of think about those market numbers we talked about earlier. So I'm going to go ahead and match the top-down approach with a bottom-up analysis. Okay, so in the US, there's about 3,500 aquaculture facilities. So thinking back to that 12% number, that gives you 420 facilities. So if each facility just purchased 2 of our licenses in 5 years, we'd be able to meet that 63 million that we talked about earlier. So again, based on assumptions, but we don't think it's completely unrealistic. Okay. I would like to say that the C Stereo team is laser focused on aquaculture, and this is truly what we started doing. With that being said, we're asked, are there other applications for this? And the answer is yes. And so I'm not going to get into the weeds on this. A note, I wish the video was playing, but on the bottom right, this is actually a wave energy converter at Oregon State University. So we're using our technology to actually track the position and create a fingerprint of the wave energy converter performance. So imagine that would be cool, not having to go out on a boat and check those things out. Um, okay, so where we're at in terms of traction and milestones. So we've been profoundly busy. This started as an academic project, and I respectfully may add, academics do get stuff done sometimes. Uh, and so the company was incorporated in the beginning of 24. We've done quite a few different programs along the way. A cool thing I would like to note, we were just accepted into the NSF National I-Corps program, which starts in a couple weeks on the backside of Oregon UAS. And then we also have our first paid pilot agreement with Oregon Department of Fish and Wildlife. So we've got some of our hardware deployed at one of their facilities there. Okay, so kind of getting into the nuts and bolts of what we're looking to do. So we're raising 1.5 million in dilutive funding. And really what this is to move 3 of our co-founders, all the way to full-time into C Stereo, right? And so thinking back to that roughly $2 million first year projection, so at the end of 18 months, this would give us 3 million in revenue, just about 36 customers, and really move our proof of concept models that are currently deployed at different locations to a more production ready prototype. Okay. All right. So wrapping up, the key to C Stereo is really the team. Okay, so we have myself, Dr. Susan Piacenza, Dr. John Fowler, that's at Cal State Fullerton. The 3 of us have been working together for over a decade, building physical prototypes, high-dollar projects for different federal agencies, right? And we're supported by our development team. So in the middle, we have Elliot, who is a co-inventor and co-founder. So he manages the AI training. He's been doing this for several years. So we have Chris Holm, whose expertise is in underwater ROVs and autonomous docking systems. Specifically, he works with wave energy converters, ocean sensing, and then finally, Kyle, our fishery scientist. He's the one that really specializes in aquaculture, and so he joined the team a couple years ago. As you can see, we do have a gap, right? And so back to that 1.5 million in dilutive funding, our business development officer is the person that we're looking for that will be part of that crew. Again, thank you so much. I really appreciate being here and having this opportunity, and I would love to answer any questions. Appreciate it.
Thank you, Joseph, for the presentation. when it comes to the data capture for the counting and the use of that AI, are you manufacturing the whole? Is it the equipment that's on board? Because you mentioned drones in here. Is
Mhm.
it the equipment on board the drone? Are you manufacturing the drone from the ground up? It looks like you're using a couple of different sensors. Can you talk to a little bit more granularity on that?
Yeah, and so I just would like to say that the drone is a feature. That's not the technology, right? And so we're just using it as a means to an end to have our stereo camera arrays from some point, depending on the situation above the water and looking in, again, through the water and the nets. So we started off a few years ago with prototypes. One of them, you saw the DJI drone, just looking at that. We have a couple of fixed systems that are actually on a like a pulley gantry system, like imagine at a football game, the camera that goes across, similar type of thing where a drone isn't necessarily required or it's just not the most practical way. And so again, the UAV is truly a feature. That's not the heart of the technology.
Awesome. Thank you. Just another quick question. So you mentioned, could you give us an idea just really quickly about terrestrial applications like, cattle, wildlife, something like that? Can it be done?
Yeah, yeah. Thanks, Joe. 100%. And so, in fact, cattle is actually they're much easier to measure. They swim less, right? And they're more stationary. And so, yeah, 100%. So the models that we have now that they can be tweaked to be a little bit more generalizable for that. So if you recall from the previous slides, you saw the data centers. And so looking at the heat maps. And so this is another thing that, in fact, we talked about most recently. Imagine looking at the roof of a data center and being actually able to track the mass of a particular heat spot or potentially water pooling, right, to mitigate any issues down the road in that data center. So again, happy to get into details later, but Joe, yeah, 100%. There's some other applications. Yeah, thank you guys.
Next up, we have Dane Littlewood with Humankind Homes. Welcome, Dane.
Testing. Okay. Well, thank you, Joe. Thank you, everybody. Congratulations to all the cohort members that have made it this far. So my name is Dane Littlewood. I'm the co-founder and design lead of Humankind Homes. As you can see, we build disaster-resilient homes and buildings assembled by AI-guided drone swarm. So in this nation, we have a compounding crisis, right? The housing crisis is no news to anybody. There's a reason for that. The National Association of Home Builders states that we are anywhere between 3.8 and 7.4 million homes short of where we need to be. Now, the reasons being natural disasters, there's no technology, no innovation that's keeping up with this demand. There's uninsurable new wood framed homes, so new wood framed construction is becoming increasingly uninsurable. And so the solution is Humankind Homes. We build non combustible structures at comparable costs to traditional construction. We are a design, manufacture, build company. So we design the homes ourselves. We manufacture our own proprietary kind blocks, and then we assemble those with drones. We're looking at the home as a product. So we're building for scale and we're optimizing for speed. So we have two core innovations at Humankind Homes, right? The first one is our kind block, and the second is our aerial masonry technology. Awesome phrase, by the way. I love that one, aerial masonry technology. So our kind block, let's start there. These are dry stackable, carbon sequestering, interlocking concrete blocks. So we remove the need for skilled labor. This means any mom and pop or Joe can stack these by themselves. They are self-aligning, as I said. And second, we have the aerial masonry technology. So we've designed a gripper system to go onto these drones that can pick and place our blocks exactly where they need to go. Our technology stack. So we've formulated an in-house proprietary carbon sequestering concrete mix. We're very proud of that. because Portland cement is highly carbon emissive. We're trying to mitigate that as much as possible. So we take that mix and then we build our blocks with that. With those blocks, we ship those onto the site where we deploy our drones. The drones, as I said, pick them up, place them exactly where we need to go or where they need to go. So here's a look at our market opportunity, right? We have a total addressable market in the United States of 48 billion. We are coming after the masonry construction markets. We plan to scale quickly as a company to address the $9 billion market that is disaster resilient homes, homes that are in high risk zones. And lastly, we plan to capture about 350 million of that over the next 5 to 7 years. Here's a look at our competitive landscape, right? A lot of people are like, what about prefab? What about 3D printed homes? I'm not denying that there's any innovation in the market, but I will tell you, if you've tried to bring any innovation to the construction industry, a lot of times you're laughed out of rooms. So these do provide some solutions, but they don't provide them at scale, right? In innovative technologies in this space, you often need ideal conditions. So you need perfectly flat roads, you need a perfectly flat site, you need massive and expensive machinery, such as cranes, equipments, haulers. Yet our blocks are small, they're transportable, easily assemblable. And so we believe that we can build where our competitors cannot. A revenue model is a three-phased approach, right? I'm just going to grab a sip of water while I keep talking to you. So we have a three-phase approach. In phase one, we're going to act as the designer and builder so that we can prove our product out in the market. In phase two, we're going to plan to get our blocks into the hands of builders and GCs, and we're going to offer them the option of automation. And then in phase three, we will offer the entire end-to-end platform. Excuse me. So let's talk productivity and scalability. Just by putting our kind blocks in the hands of GCs, when we offer our kind blocks to them instead of traditional masonry, we already see an increase in worker output. Now, when we introduce the automation portion of our business, so the drone automation, that's where we see explosive scale. We're partnered with a nonprofit in Portland, Oregon called the Missing Middle Housing Fund. Through them, we've already generated tons of really great relationships with landowners, builders and developers, GCs. But beyond that, we've actually been working with the public sector. So we've been working with mayors, city managers, authorities having jurisdiction. So we're seeing a crossover and a collaboration actually between private and public when it comes to deploying housing. We project that our kind blocks alone, getting again our kind blocks sales, that alone is enough to generate sustained revenue for Humankind Homes. But we have two other revenue streams, which are getting our automation, getting the drone assembly portion as an offering to these builders and GCs, and then eventually the licensing of our entire platform. Yes, traction and milestones. So we were founded back in 2018. This company was actually born out of necessity, right? So homes can be built quickly, they can be built cheaply, but we didn't quite see, where we could build quality homes quickly that were built to last. And so that's when we started in 2018. Just a little backstory. In 2024, that was a great year. We received $500,000 from the Missing Middle Housing Fund to prove out our pilot project. Our pilot project is actually, we've broken ground on the site. This is in Newberg, Oregon. If any of you are familiar with that area, come find me. I'll tell you the address. You can come check it out. The Oregon UAS cohort. We are cohort members, cohort 3. Thank you, Joe. Thank you, Chris. Thank you, Ella. This has been great for us because we've actually had a chance to really accelerate our drone development. And then lastly, by the end of this year, 2026, we plan on having our paid pilot finished, complete for people to walk and check out and kick the tires, as many investors say. So our ask, we are asking for 1.5 million. We are raising that on a convertible note. We already have a lead investor with a signed term sheet, raised 100,000 on that. We are willing to tranche our funding, starting at 650K to get us through the rest of this pilot project. However, if we can get to this 1.5 million, this will get us through our pilot project, and this will get us into our facilities with the equipment we need to continue production. Here's a look at our team. I myself, Dane Littlewood, I'm an architectural designer by trade. I've worked in architecture and engineering firms. I've headed and formed AI tech committees in these firms. I love what I do. Our co-founder and CEO, Elliot Kahn, he's in the crowd here. You can say hello to him after. He is the bachelor in robotics and mechatronics, so he's definitely the drone guy. And then our most recent hire on the end there, Keith Mosier. He is our COO, Chief of Operations, and our cybersecurity specialist and IT expert. I want to give a awesome shout out to our advisor here, Ryan Olson. He has over 30 years of experience in real estate development, and he's brought his own construction innovation to the market. And then here's just a couple of our partners and programs we're in. So thank you so much for your time. Really appreciate it. Here's a picture of us at our groundbreaking down in Newburgh. Again, come find either myself or Elliot Kahn in the back here. We're here to answer any questions that you have or keep the discussion going. Thank you.
Thank you, Dane. Good. Thank you so much. No questions.
Yeah, thank you all.
All right. Next up, we have Haas. Welcome. Yeah. Oh, sorry. Is that one?
Test. All right. Over the past decade, healthcare has been consolidating. Today, most hospitals in the nation are part of a larger system comprising of centralized labs, blood banks, pharmacies, and specialty treatments. While this, in theory, improves patient care, it relies on fast, reliable, and on demand systems of transportation that conventional courier networks weren't designed for and are currently unable to meet. 40% of providers have had to cancel or reschedule cases at least quarterly due to product shortages. On the hospital side, that's roughly $25 billion of unnecessary funding. Right now, there is no fast or reliable way to move critical medical supplies between hospital systems at scale. As healthcare continues to consolidate, the logistical infrastructure on which it so heavily relies on lags years behind and can't keep up. Hospitals continue to rely on inefficient and unreliable ground couriers, as well as expensive and fragmented helicopter and jet charters. At Haas Autonomous, we are solving the problem of inefficient transport of high value supplies with our autonomous drone delivery system. Featuring 30 to 90 times faster dispatch, the safest transport conditions of any courier ever, and fully integrated chain of custody. Our platform features a proprietary autonomous aircraft as well as accompanying coordination software. Through our software, customers can request aircraft, track their shipment live. This should be a video, but I'll walk you through it. Track their shipment throughout the flight and fully integrate chain of custody. Our algorithms optimize for allocation, taking into account aircraft telemetry, weather, ATC coordination, and FAA flight zones. The aircraft itself is a patented fixed-wing electric vertical takeoff and landing capable vehicle, allowing us to utilize hospitals' existing helipad infrastructure while also achieving ranges of over 110 kilometers. Furthermore, our proprietary patent-pending specialized payload compartment controls for temperature, pressure, vibration, and tilt, while allowing customers to use their existing transport boxes, requiring no changes in workflow. Historically, this is a huge area that other companies trying to break into the space have struggled with and failed to integrate into their aircrafts. As we don't require any changes in infrastructure to begin transport, We have zero upfront costs for our customers. They will only be billed for the flight through a proprietary pound mile billing system that we built alongside organ procurement organizations and hospital systems. For early innovation partners, we are offering our services at a 10% discount than what they currently pay with conventional couriers. And now is the perfect time. Regulation is finally catching up, and the FAA is moving towards Part 108, enabling scaled autonomous operations across the United States. In 2020, we had 1,229 BVLOS waivers issued. That number in 2023 jumped all the way up to 27,000, so you can imagine what that is now. My name's Santiago Brent, and I'm a former full-stack embedded systems design engineer over at AMD. I'm joined by my co-founders Jason Chen, who previously led Rice University's rocketry team, and Ege Halak, who's been working in the medical industry for over 7 years. As the first undergraduate team at Rice University to sponsor a senior design project, we've developed a fast, capital-efficient hardware iteration process, completing 13 prototype iterations in just 16 weeks. We now produce each aircraft for under $1,000 and are able to build a new unit every 20 hours, allowing us to manufacture at scale. Our advisory board consists of Michael Kielander, the CEO of Airspace Link, who's been extremely helpful in allowing us to obtain the necessary FAA waivers we need, as well as integrating our software into air traffic control. We're also joined by Dr. Joseph Scalea, a transplant surgeon and pioneer in the field of autonomous medical transportation. Thus far, we've spoken with hundreds of potential customers across the entire medical industry and received 4 letters of intent for our services. We've also been guaranteed the world's first clinical trial for organ transport. And on the regulatory front, we've received full authorization to fly our aircraft and are currently integrating our software and allocation system with air traffic control. On top of this, we're one of the beautiful 12 teams selected for this wonderful Oregon Pendleton UAS Accelerator. So, in our mission to scale autonomous aerial logistics, we have raised $1,150,000 from venture capital and plan to close out our $2 million round by the end of this month. We've raised this capital to convert our pilot trials to customers by early 2027 through established CAPE that we've been working on HOST. We've been independently contacted by people in the seeding industry, oil and gas, semiconductor manufacturing, maritime vehicle deployment, and more. This issue doesn't just exist here. So, if I can leave you with one sentence to remember about HOST Autonomous, we're building the fastest, most secure logistics layer for the world's most sensitive cargo. Thank you, everyone.
Thank you. Questions?
I thank you for a good presentation.
Of course.
How does your hardware differ from competitors? And cost-wise, what does it cost to manufacture, and what is going to be your financial margin?
All right, great question. So I'll answer that first one. So primarily, the cost of actual manufacturing is that 1,000. I have a previous slide. The actual cost of goods sold on the entire drone for the airframe itself, because we're using 3D printed and carbon composites, is under $100 right now because we do everything in house. That actually makes it so it's cheaper when we begin to manufacture at scale. It's primarily the avionics we have, which make it so expensive. And then, as for your first question on how our hardware differs, we're actually using a quad tilt rotor blended wing body. Because of this, one of our biggest selling points that I previously touched on is we're payload agnostic. A lot of companies struggle with utilizing the pre-existing boxes that hospitals use. And as most people know, hospitals hate to change their workflow. So we need to integrate entirely with what the hospital workflows use, which means we need to be entirely payload agnostic, which is why we chose these hardware design choices so we can utilize their pre-existing transport boxes.
Sorry, one more question for you.
Of course, no.
What's
Keep 'em
the
coming.
payload capacity?
It's 4 kilograms right now.
Okay.
This is
Thank you.
currently a quarter scale model, though. We plan to scale out 4 times.
So I have a question.
course.
I don't know if you mentioned this, but live organ transplant, is that a possibility using the payload that you currently are developing?
Yes, so right now we're using a quarter scale model, and this is primarily for cyanide poisoning kits, toxicology samples, blood, urine, etc. And that's just to prove out and kind of demonstrate our product to our customers. From there, we want to scale up the aircraft so we can actually utilize hypothermic and normothermic perfusion devices, which is basically dry ice or pumping blood in the organ. And that will be the full scale aircraft because those tend to be like 100 pounds, whatnot. And with those, we're going to use a hybrid gas electric system, which will allow us to have 500 to 1,000 miles of range that we've achieved through CFD, model testing, etc. Any other questions? Awesome.
Thank you so much. Our screen went blank. Is there a reason? There we go. All right. So this concludes session one of our startups. I'd love everyone to give our startups a big round of applause for coming up. And so this is your opportunity. Please use your phones, scan the QR code, and you'll be able to vote for your fan favorite startup, or what we call the People's Choice Award. So I'll give you a few minutes to do that, and then we'll move on. Maybe.